Biomechanics is the study of the human body at rest and in motion. It involves examining the force acting on and within biological structures, as well as the effort produced by force. Part of this study involves levers. Levers are a rigid object that rotates around a fixed point called a fulcrum. Rotation occurs when effort or the in force overcomes resistance, which is the out force, which essentially means as I sit here and I try to bicep curl this dumbbell, my tendon or the effort is trying to bring my bone up, but the dumbbell acts as the resistance, which is weighing it down, which requires more effort of my tendon to bring that dumbbell up and resist the resistance. Within the lever system, there are 3 different classes. The first class involves the fulcrum being in the middle with resistance and effort being on the outside. The second class is where resistance is in the middle instead of fulcrum. And then the third class is with effort in the middle. The best way to remember them is F as first, R as second. Mechanical advantage is the ratio of output force to input force and is calculated from the length of the fulcrum to the effort divided by the length of the fulcrum to the resistance. As an example to calculate the mechanical advantage, we're going to take a look at the biceps. First, you want to find the length of effort, which is the fulcrum to the effort, and that's 2. Let's say that's 2. And then you look at fulcrum to resistance, and we'll say that's 5. Okay, and then you take the length of E, which is 2. And then we're going to take the length of fulcrum to resistance, which is 5. And then we're going to divide that by itself, and together we'll get 0.4. The reason biomechanics is so important is because not only does it help prevent injuries, but it can also help improve someone's sports technique. It looks at small details and uses that to calculate the optimal position and movements for athletic performance.